Example 3. For each graph of a function y equals f of x, find the absolute maximum and the absolute minimum if they exist. Also, find any local maxima or local minima. All right, so there are 3 different graphs that we're going to take a look at, and this is the layout of such a question that I will give you on either a quiz or an exam. I will give you a picture of the function, and then as far as stating the extrema, it will be fill in the blank. Okay, let's take a look really quick as to how one of these statements is laid out. So if we'll just look at this first one, if you're identifying an absolute max, you can identify it on the graph, and then to write it down, it says the absolute maximum value of this function is y equals blank. Okay, remember that goes back to this statement up here that says that the y value is the max or the min value. Okay, so when you state max or min, you're stating the y value, and then the x value is just where it's occurring. Okay, so that's how all of these statements are going to be set up. Okay, so again, to identify the max or min, whether it's absolute or local, you will be writing down the y value, and the x value is just there to state the location of your extrema. Okay, all right, so let's get started on part A here. So we've got our function. We're going to first try to identify the absolute maximum. Okay, so the absolute maximum is going to be the highest point on the graph. Okay, so that's going to be this point right here, which is 3, 6. I'm going to go ahead and label it in the picture. There's your absolute max. So basically what we write down, the absolute maximum value of the function is 6, and it occurs at x equals 3. Okay, that's how you want to think about it. Okay, the function value at this point is 6. It is occurring at x equals 3. All right, next, absolute minimum. That means the lowest point on the curve. Okay, so the lowest point on the curve, remember, if you're doing the highest or the lowest, you have to be able to touch it. Okay, positive and negative infinity don't count. Okay, we can clearly touch the lowest point on the curve here. Okay, this is going to be the point 0, 1. Okay, this is going to be the absolute minimum. Okay, it is okay for absolute extrema to not occur at a hill or a valley. Okay, the absolute max here occurred at a hill, and that's okay, but the absolute min does not occur at a valley, and that is okay. Local has to occur at a hill or a valley. Absolute, that's not a requirement. Okay, so 0, 1, that point corresponds to the lowest point on the graph. So we're going to write down the absolute minimum value of the function is going to be 1, and it occurs at x equals 0. Okay, next we're going to talk local maximum. Okay, so we need to be looking for the top of a hill. Okay, I see one top of a hill. Okay, it's the same point as the absolute max. Okay, so 3, 6 is not only an absolute max, but it's also a local max because it's the top of a hill. I don't see any other hills. Okay, so our only local maximum value is going to be 6, and it occurs at x equals 3. Okay, and then lastly, we're going to identify any local minimum values. And let's see here, we're going to be looking for the bottom of a valley. Okay, and that's going to be right here. Okay, this is going to be your local min. Okay, again, you don't want to pick the green value here or this 0.01 because yes, it's the lowest point on the curve, but it doesn't happen at the bottom of a valley. Okay, local has to occur at a hill or a valley. Okay, so 4, 4 is the point that represents the local min. Okay, so the local minimum value of this function is 4. Okay, and it happens at x equals 4. Okay, all right, so let's take a look at the next one. Okay, so in part B, we have a different graph here. You should notice before we even start talking about this graph that we have something different here. If you focus on the point 3, 1, that's an open circle. Okay, so remember, open circle versus closed circle. Closed circle means it is part of the graph. Open circle means it's not part of the graph. Okay, so don't forget that. We're going to see if that makes a difference in terms of maxes and mins here. Okay, all right, so first point here, we need to find the absolute maximum value of this function. Okay, so can you touch the highest point on this graph? Okay, well, yes. Okay, it's going to be this point. Okay, so this point 5.3 is going to be the absolute max. So we say that the absolute maximum value of this function is 3. It occurs at x equals 5. And then we want to locate the absolute minimum. Okay, so we need to be able to touch the lowest point on the graph. Okay, the lowest point on the graph is going to be the open circle. Okay, so the question is, does it matter that the point 3.1 is open? Well, 3.1 is not actually part of the graph. So it can't be the absolute minimum because it's not part of the graph. So the question becomes, well, do you pick a point close to it? Okay, maybe that point is 3.0001, 1.0001. Okay, maybe you're like, that's the closest I can get to this point. Well, theoretically, you can get even closer. Okay, just put another 0. And then you can get even closer by just adding another 0. Okay, so the point is you can get infinitesimally closer to that open circle from either direction, whether you're traveling on this portion of the curve or you're traveling on this portion of the curve. You can get closer and closer, like infinitesimally with all these decimals, trying to identify a point extremely close to the open circle. Okay, but you can always add a 0 and find a point closer than the one you're currently at. So since you can always get closer, you can't identify the lowest point. Okay, so to just make it easier here, there's going to be no lowest point because of the open circle. Okay, so we're just going to go ahead and say none. Let me put it in a different color. We're going to say there is no absolute maximum. And I'll put out here because the point 3.1, had it been closed in, that would have definitely been the absolute min. Okay, because 3.1 is an open circle. So it is not part of the graph. All right, let's take a look at local max. Okay, when you're looking for a local max, you need to be looking for the top of a hill. I don't see one. Okay, so yeah, we can pick 5.3, which is the highest point on the graph, but that's the absolute max. Okay, if you're dealing with local, 5.3 is not local because it's not at the top of the hill. Okay, so we're going to go ahead and write none here. Okay, there's no top of the hill. All right, lastly, local min. Okay, local min would be the bottom of a valley. Well, guess where that is? Back at 3.1. Okay, this is definitely a valley. Okay, and the point 3.1, which is the open circle, is the bottom of that valley. But just like the absolute min value, 3.1 doesn't count because it's an open circle. So, you know, had 3.1 been closed in, then 3.1 would definitely be the local min, but it's open, so it's not included. So we're just going to go ahead and write there is no local min. Okay. All right. One more. Hopefully you're getting the hang of it. Okay. There's also an interesting feature in this particular graph. At x equals 5, there is a vertical line going through it, and it is a dotted line. It is a vertical asymptote. Okay, so basically what that means, the blue curve is your graph, and over here you see the arrowhead going down. The graph is getting closer and closer to this dotted line, but it never crosses or touches it. Okay, So just keep that in mind as we do this problem. Okay, let's start with absolute max. Okay, so you need to be able to walk up to this graph and touch the point that is the highest one on this graph. Okay, well, the highest point on the graph is going to be 1, 4. Okay, again, we see an open circle. So 1, 4 is not part of the graph. Okay, so it's going to be very similar to what we saw in part B. Okay, if you try to pick a point that's actually included on this blue curve, but you're trying to get closer and closer to the point 1, 4, okay, maybe if you started here and this is like 1.01, 3.4 or something, you can always pick a point that's closer to it. Okay, and then you can always pick a point closer and then a point closer, and then you're dealing with decimals at that point. All you have to do is add a 0 to get a point that's even closer. So you keep getting infinitesimally closer and closer to this 0.14, but you can never get there, okay, because you just add a 0 and you get even closer. Okay, so because of the open circle, you can't count that point. Okay, so 1, 4 would have been the absolute maximum had that point been closed, but since it's open, we can only conclude that there is no highest point. Okay, you can't count something like this because again, you can get higher. You cannot count something like 4, 3. You might be tempted to count 4, 3, but remember, this is a point right here on the curve that's even higher than 4, 3. Okay. All right, so no absolute maximum here. What about absolute minimum? Well, you have to be able to identify the lowest point on the curve. And if you look over here towards the vertical asymptote, the curve is going down, 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 down forever. Okay, so it's headed in the direction of negative y. It's headed off, the range of this graph is negative infinity to y equals 4. Okay, so because the graph is going down, 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 down forever, you cannot touch the lowest point on the graph. Okay, so there is no absolute minimum. Do not write in negative infinity. Do not write negative infinity. Okay, if you're dealing with a max or a min, you have to have a specific point that you're talking about. Okay, so again, here there's going to be no absolute minimum. Okay, all right, local maximum. All right, so we're looking for, if you're looking for a local maximum, that means top of the hill. Okay, well, I see one hill right here and 4, 3 is at the top of the hill. Okay, so this is going to be a local max. Remember, this local max is not the highest point on the graph. For example, this point is higher. Okay, we're not worried about that. We're just trying to identify the top of a hill. Okay, so we have a local maximum value of 3. It happens at x equals 4. Okay, last one, local minimum value. Okay, we're looking for the bottom of a valley. Okay, so bottom of a valley, I see a valley right here. 2, 2 would be the bottom of the valley, but since it is an open circle, it does not count. Okay, so once again, we can conclude there is no local minimum. Okay, for the same rationale as stated above. Okay, if you try to pinpoint the lowest point on, or this in the lowest point in this little neighborhood, you can always add a decimal and find a point closer, trying to get to 2, 2, but because you can add as many zeros as you want, you can't identify the lowest point in that little neighborhood.